Okay, here's the video for Unit 2, Day 3. Our learning targets, I can write an algebraic expression or inequality from words, and I can identify an inequality with no solutions and infinitely many solutions, and differentiate or tell the difference between those two. So first off, you're put in a garden right next to your neighbor's garden, and you have 42 feet of fence to put around the outside of the garden. What are the possible lengths of your garden? So first off, if we look at this guy, so we got the perimeter at most 42. Okay, so that's just kind of like the words in our heads we're thinking. So P at most less than or equal to, and then 42. Well, perimeter is actually 2L plus 2W, the perimeter of a rectangle. So that needs to be less than or equal to 42. And in this case, what would be my width on this guy? So I need 2L I'm sorry, this is my neighbor's garden. I should say WWLL here. I got it backwards. Okay, so here's the neighbor's garden. Here's my garden. I'm going to put it right next to it, so I have to have the same width as him. Well, he has 12 foot, so I'm going to do 12 foot. Okay, so subtract 24 from both sides. So 2L has to be less than or equal to 18, which means L has to be less than or equal to 9. Now, if I did 9, so this is 12, 12, 9, and 9, I would use up all 42 feet of fence that I bought. If I do less than that, it's still a garden, and I still have enough. I'll just have some fence left over. So we're not always trying to find out how to use all of the fence. We just know what are the possible lengths. Well, my length has to be more than 0, obviously, but it has to be less than or equal to 9. Okay. Another example, your cell phone plan costs $39.99 a month. So that's just to use your cell phone, just to be on their network and make phone calls and all that, plus 15 cents for each text. So this, maybe you guys don't know what this is because your whole life texts have been free, but there used to be a time where you had to pay for the text when it was new. So that's kind of what this problem is based off of. It doesn't maybe seem so applicable now, but it's a good practice math problem. You budgeted $45 for your cell phone plan. So if you don't make any texts, you'll be fine because you'll stay under your budget. $39.99 is less than 45, but you could obviously make a few texts in there. We want to know what's the most that you can make. What's the maximum number of texts that you can send or receive? So the $39.99 is not affected by the number of texts. That's just a constant. That's what you're going to pay. Plus 15 cents per text. So this right here, if I add those together, that's my cost for using the cell phone this month. We're going to pretend like there's no fees or taxes or any of those kind of things. And now we want that to be at most. At most means up to, so it can be less than, but it can't be more than. So up to or equal to, so less than or equal to 45. Okay, so here's the cost, at most 45. Just like up here, at most means less than or equal to, so at most less than or equal to. And then go ahead and solve that. So subtract $39.99. I got this would be 501 divided by 0.15. So it has to be less than or equal to 33.4. So how do we want to round that? Because we can't send 4/10 of a text. Now if I send 3 texts, I'm fine. Because 33 is less than or equal to 33.4. But if I send a 34th text, I'm over. So when asking how many texts could I send, the real answer is it has to be less than or equal to 33. Okay, we can only send 30. If we send that 34th text, we're over. Now we busted our budget. Okay, so Next one, the student council wants to rent a ballroom for the junior prom. The ballroom's rental rate is $1,500 for 3 hours and $125 for each additional half hour. Suppose the student council raises $2,125. What's the maximum number of hours for which they can rent the ballroom? What we're going to do, we know we have enough money for 3 hours because 1,500 is less than 2,125. So let's just say we're going to do that 3 hours. We want to know how many additional half hours we can do. Okay, so we'll say plus $125 per half hour. Now we could do it this way too, because that would be per 1 half hour. You could also say, well, what is it per hour then? So if it's 125 for each additional half hour, and we want to know the maximum number of hours, we could actually convert this. That'd be 250 for 1 hour. So we'll just say 250 times x. So $250 for every hour plus the 1,500, and that needs to stay under, so less than or equal to 2125. Okay, so now we're going to solve for x, so subtract 1,500. I get 250x needs to be less than or equal to 625. Now divide by 250. So x, let's see, so 625 divided by 250. X needs to be less than or equal to 2.5 hours. We can leave that as 2.5 because they do charge us by the half hour, so we can leave it 2.5. We don't have to round down to 2 hours. So this one's okay. So we could do up to 2.5 hours in addition, actually let me put this, in addition to the 3 hours we already rented. Okay, so this was how much additional to the 3. So really, I'm sorry, this should be x less than or equal to 5.5. That's my final answer there. I solved for x, but this was 3 hours here, so we have to add 3 back to it. Okay, backside. Remember from Unit 1 that most equations have one solution. However, some had no solutions, while others had infinitely many solutions. Okay, this is also true with inequalities. Okay, there are ways, like the ones in the front, we got solutions, but there are ways where we could get no solutions. Okay, so let's look at some of those here. So this guy right here, let's solve this guy. First, I want to distribute the 2 out. So 10 minus 8x would be greater than or equal to 10 minus 8x. And look at that, isn't that kind of weird? So this expression, it's the same on both sides. So it doesn't really matter what I plug in for x. It's going to be the same thing. But let's pretend like we didn't see that. Let's continue. So I'll subtract 10 from both sides. And then we'll get the x's together, so I'm going to add 8x to both sides. I get 0 is greater than or equal to 0. Okay, so what happened? Well, at some point the variables disappeared. Okay, so the variables disappear. So if they disappear, is this a true statement? Is 10 greater than or equal to 10? It is. So we say this equation has all real number solutions. All real number solutions, since the remaining inequality is true. So all real numbers works for this one. Okay, we said infinitely many. This kind of replaces the infinitely many because all inequalities have infinitely many. So this one, it's any number. It's not just that there's infinitely many solutions, it's any number you choose. Well, and that's because this was true. My light went off on me. So this is true. Let's keep going here. Solve the inequality. So here's another situation. I got 6m minus 5. Over here I got 7m minus m is 6m. And then I got 7. Let's get the m's together. And I get negative 5 is greater than 7. Again, what do I notice? The variables disappeared. But on this one, is that a true statement? Is -5 greater than 7? No, it can't be. It never happens. So we say this has no solution. No solution, since the remaining inequality is not true. Okay. Solve the inequality if possible. So let's go kind of faster, and I'll probably leave one of these open for you to do. So let's see, I'll distribute the 3. So this would be -3w plus 9, because I got a negative times a negative, is greater than or equal to 9 minus 3w. Let's get those w's together. So if I add 3w, I get 9 is greater than or equal to 9. And that is a true statement. The variable has disappeared. Okay, so up here the variable has disappeared, but it's a true statement. That means all real numbers. So all real numbers. Okay. Video is getting kind of long here, so I'm going to stop there. I want you to try these two. So finish for credit. If you don't have those finished, you don't get credit for doing notes, so try those out. Okay, definitely try those out and see what you get.